So today's service call is on a water leak coming from a AC unit on the roof. So check it out. It's not leaking right now, but they said over the weekend it was leaking pretty good in their bar area. So get going on it, check all the usual suspects. I can already tell you that I don't like how close that P-trap is on that drain. And that would cause stuff to gum up that P-trap really quick. But don't know if that's the cause, so we'll see. So I went ahead and pulled the filters out. The evaporator doesn't look too dirty. And the drain pan is not full of water, that's dry. The ducts is kind of hard to show on the camera, but I can see down into the ducts and they don't look like they're wet anymore. No, they were wet at one point. But yeah, nothing, no water down there, so maybe we'll see. So we're gonna go through everything and check everything out. We'll start with just the basics, checking the belt. See if there's anything funky there, then we'll fill up the drain pan with some water and see if we have a slow drain or something. Don't see any problem with the belt. It's nice and snug. No unusual wear. Looks like it's good. Pulley looks fairly new. See a problem with that. Indoor blower wheel's dusty, but it's not horrible, so I don't see a problem with that. So far we're looking good, so I'm gonna have to dig into that drain. Here's something that you guys want to watch for. We're seeing a dry drain pan, right? So there's not a problem there, but your filters are a great indicator of a lot of things. And if you look at this filter right now, just visually, you can tell that it has gotten wet, okay? The whole filter is warped. It's dry now, but it's warped. If you run your fingers across it, it's got ripples in it. Okay, now, let's keep looking at all the filters. Again, same thing on this one. I don't know how well it comes through, but you can see the water, like you can see right there. Same thing, it's warped, okay? So let's keep going. Let's find out if it's all the filters or just the bottom. And this filter is the same. Same thing here. So all 4 filters have gotten wet. And what that indicates to me is that we had an iced up evaporator coil. Now it's not iced up right now. We're gonna go through the system. We're still gonna check the drain and everything. But again, looking at the big picture, investigating everything, just looking at those filters, this is a really good indication that this was an iced up evaporator coil. And it thawed itself maybe, I don't know. But something was going on there. So we will keep checking everything out. So the unit does have a slow drain. I filled up the drain pan with water and it's just sitting there. I still don't know what caused the filters to be wet, so we'll look into that in a minute, but yeah, the drain is very, very slow, so it's just sitting there with water. Over here, it's just sitting in there. So there's something going on there. That is all that I'm getting out of that drain pan through that P-trap right now. So usually, if you, there you go. Breaking it free right now, so the chunk's coming out. So we've just got to plug that P-trap. We'll clear everything, and I'm going to go ahead and redo that P-trap. So I'm currently mocking up a new drain. I haven't soldered anything on yet. I just want to point out a few key functions. Number one, I have 2 T's, okay? This one right here is a vent, okay? This allows the water to drain faster, essentially, okay? And helps it so it doesn't get vapor locked, I guess you can call the word. I don't know if that's the right word, but basically by putting the vent on there, it helps the flow to flow better, okay? Now, you see this one right here. This right here is a clean out, okay? This vent can also be used as a clean out, but it's important that this clean out right here has to have a cap on it, okay? And the reason why it has to have a cap on it is because this drain is on the return air side of the AC unit. And let's go ahead and step in here and I'll show you. Okay, so this is the return side of the unit. And what's happening is the blower motor is pulling the air through this section, okay? So what happens is we create a negative air pressure in this whole cavity right here. If I put a manometer on here and close this panel up, it would be under a negative air pressure. And what happens when we have a negative air pressure is you have to have a P-trap on your drain line, because if you don't, the unit itself will actually, the negative air pressure will actually prevent the drain from draining. okay? Because that negative air pressure will actually suck air through this drain, through here, into there, and then the water will just sit on the other side and just ripple, okay? And it won't let the water come out. It's very interesting. And then what would happen is you would get a call of a water leak, and you'd go in there, and then when you shut the AC off, all of a sudden, whoosh, all the water would start draining out of the unit, okay? So I'm gonna put a riser on here with a cap, and we're gonna leave it unsoldered, and that's just for when people are doing PMs, they can come through and blow this P-trap out, okay? Now, it's important that we put some kind of a disconnect right here. I happen to have a union, but previous, there was just a coupling right there, which is also fine. It's a common practice of ours to take a coupling and just put electrical tape on each side, and that indicates to the next guy that this is a loose fitting and you can take it off to clean out the drain, okay? But luckily I have a union, so I'm gonna go ahead and put a union right here and eliminate that problem. Now, sometimes I like to put a vent right here too, or a clean out. I don't happen to have one right now, so I'm not gonna be able to do it on this one, but because this is a 1" to 3/4, I'll go look at my van, but I don't think I do. But sometimes I like to put a clean out here too, because then you'd be able to clean out the main line, you'd have a vent, and you'd be able to clean out the P-trap. So the cool thing about this is the theory is if this drain gets plugged up, you pull this cap off that I'm gonna have there, and you just blow all the crap right out of the drain. Because the water is gonna take the path of least resistance, so it's gonna just blow right out of that trap. Okay, so I haven't soldered anything yet. You know, as usual, even when you're brazing on refrigeration copper, cleanliness is your best friend. So I got to go in here and clean up all these fittings, put some flux on them, and then I'll solder them all together, and then I'll go down to my van and get that riser for right here. But I just want to make sure you understand the importance on this. Also applies to residential air conditioning split systems too. If your blower if your evaporator is on the negative air pressure side, which a lot of times they're not, but you know, sometimes they can be. If your evaporator's, you know, on the negative air pressure side of the system, then you have to make sure you have a P-trap on that. Now, if it's on the positive air pressure side, so most like closet units, you know, they'll throw, at least here in Southern California on the resi side, they'll throw the evaporator on top of the furnace, so it becomes positive pressure, and you don't really have to worry about a P-trap when you have a positive pressure system. But I will preface by saying always read the manufacturer's instructions. Sometimes they might do some funky things. You got to be careful. Also, you always have to be careful because sometimes on the older Carrier units, they had an internal P-trap on the inside of this drain pan. And if you put another trap, it would be double trapped and it wouldn't drain right. So you have to understand, I'm not going to break this unit apart, but it's just a standard drain pan. There's no trap internally. On the older units, they would have a sticker right here that said trapped internally. But you know, as they got older, the sticker faded off. But it's always important to understand what you're doing and how you're doing it. So I'm looking at this and fixing this drain to eliminate this really, really tight, you know, P-trap, because all that junk is what came out of that drain. And this particular customer gets a regular preventative maintenance where we blow out these drains quite often. Why this trap is becoming a problem now when this unit's been here for 10 years, I don't know. I still don't know that this is the only problem, but I do know that this trap was dirty. So I just took the opportunity to go ahead and replace the drain and then pipe it better, you know, so that way we can, you know, maintain it better. All right, so this is what we're coming up with. I ended up finding the fittings that I needed to go ahead and finish this. So now I have a full system, so I can take it off at the union here, take it off at the union here. That way, if I need to clean the evaporator drain, I can clean out the P-trap. There's a cap on there, so that way we don't get the negative air pressure holding the water back. Yeah, so now it's just time to solder everything together. So another important thing that I want to point out that I make sure is that you want your vent to be lower than your drain. And the theory behind that is if the main drain was to ever plug up, you want it to come out of your vent and not back up into there. So functionally, the vent will still work the same if you ran a riser just as long as that one. But the problem is that if the drain was to plug up and you didn't have this T here, the water would back up into the unit. Okay? Sometimes the reason why I bring that up, like this particular location, they piped in like 3 ACs. So if we get a main drain blockage, it'll come up on the lowest AC drain. And if I had how it was before, just that 90, then it would come up the 90. And then if the original vent was higher than the AC, the top of the vent, it wasn't, but if the top of the vent was higher, then it would back up into the AC. So that's another important thing. So this is all done, it's nice and snug and tight. So we can blow out the main drain, we can blow out the P-trap, or we can blow out the P-trap from the other way, and this right here is always going to be left loose. But remember, because of the negative air pressure where the drain pan is on the unit, it's on the return side, we have to keep this on here, and we have to keep water inside that trap. That water is what's preventing the negative air from coming in through the drain and preventing the unit from draining. Okay, so there's always got to be water in the trap. Another thing that a P-trap does, this is on an RTU unit, but another thing a P-trap does is it helps to eliminate any odors that could potentially come back up through the drain. Say for instance, it's very rare that this is hard piped into a main sewer line, okay? I doubt you'd see something like that. All the codes in the world prevent that. But sometimes it might be going down into a floor sink somewhere downstairs, and there might not be a big enough air gap. And so if that floor sink was to back up or something like that, you could get smells coming in through the drain. So the water in your P-trap is gonna prevent those smells from coming up into there. So that's an instance where it might be justified to put a P-trap on a unit that has the evaporator on the positive, or the drain pan on the positive air side, because if it's draining into an unwanted place where odors could come back up into that, you may want to look into that. So okay, so I'm all finished up, well, at least for today. And here's my dilemma. This unit has got a smart, I shouldn't say smart, it has like a cheesy energy management system. They use Bay Web thermostats, so they're internet controlled thermostats. And I have no real control over them. They're locked out, customer has them password protected, but the problem is that they've had this system here for 3 years, and facilities, long story short, doesn't even know that this restaurant, or doesn't remember that this restaurant has this. So when I called to talk to facilities, they got to do some research. So there's no way to test the system. My theory is that the thermostat is not shutting the unit off. The only thing this unit has going for it is that it does have a Honeywell Jade economizer, and when it gets cool enough outside, it's going to open the outdoor air dampers and shut the compressors off. But yeah, so it's kind of a dilemma. I really can't go any further until the customer gets me access to their system. So that's kind of where we're at. So I mean, I could shut the unit off, but I just worry that it was freezing up. Because like I said, I showed you guys the thermostat, the filters, and the filters were nice, and you could tell watermarks. But other than that, refrigerant pressures are running great, so everything's good. So we're just gonna have to follow back with this one. All right, so I went back out and followed up with the customer a couple days later. Everything was still going good, no other problems, no other water leaks. The facilities department finally got me access to their Bay Web dashboard, so I can actually log in, and I was able to log in, turn the unit off, and verify that the actual thermostat module was turning the unit off, and it was. So at this point, we're just gonna, or I just told the customer just to keep an eye on it, and we'll see if we have any other issues. It's a good thing that I ran into this, because now I actually have access to that Bay Web dashboard, which I do have to say too, I'm really not a fan of the Bay Web dashboard. It's not very user-friendly, and it's very confusing, but that's another thing. Hey guys, really appreciate you guys taking the time to watch my videos. Please consider subscribing to my channel. Give me a thumbs up. Leave me some comments. Also, subscribe to the other channels that are popped up around me right now. Those guys got some great content, so let's spread the love and check out their stuff too. Okay? That's pretty much it, and I will see you guys on the next one, okay?